that having a graphing calculator makes this a little easier, but it's not a necessity, let's say. So what I'm going to do is I'm going to do the first couple of problems here on the front, and then I'm going to do a couple of the multiple choice ones on the back, which you're going to love. They're really easy, just to kind of give you a start. So when you're done with the quiz, you're going to be able to go back and see how this works. So let me pull the calculator up here, clear things out. So here's my deal. The first one I'm going to do strictly using the calculator. The second one I'm going to show you what you can do, for instance, if you didn't have a graphing calculator at your disposal. So y equals, we'll go ahead and get that in. And I'm going to type what I see. So 2 parentheses 1 divided by 3, because I got a fraction. And again, before I hit the x, for that to be an exponent, I need to hit the caret. And then that x is right next to alpha. So it should look like this. Once I do that, to get my points, I'm just going to hit second and graph. Now we talked a little bit yesterday about we don't want to just do all these decimal ones because that's kind of hard to tell what's going on. So if I see a lot of decimals, maybe I start moving up a little bit so I can see some more values. So for instance here, I'm not going to fit 54. That's a little too big. But like negative 218,
Why are you doing negative?
well, let me show you. If I'd have just stuck with 0 and after that, like this, I'd have done this, and I'd have started getting all of these decimals, and I'd have thought my only part of the graph is just this little bit. But it's not. It actually goes further than that. So I was just looking to see if the numbers would let me see it a little bit better if I went into some of the negatives. So here, by using a couple of the negative numbers, I get to see the full effect of the graph. The other thing that hopefully you'd know at this point is when it goes down to the right, that's decay, and I know it's decay because the value in the parentheses is less than 1.
What do you call it if it goes left?
Well, it's either going to go down to the right or it's going to go up to the right. We always just kind of look at it that way. So if it goes down to the right, it's decay. If it goes up to the right, which this next one's going to, it end up being growth. So let's say, because one of the things we discussed yesterday was, well, what happens if I don't have one of these fancy calculators available to me? You know, can I not do the homework? No, there's still a way we can do this. Let me just swing this over here. Let me show you how this would work if I didn't have a fancy calculator. So I look at this and I'm like, okay, 3 times 2 to the x. What I typically do, I'm just going to start with these 3 numbers and kind of see what happens here. I'm going to literally type into my calculator 3 times 2, but instead of when I hit my caret, instead of hitting x, I'm actually going to start plugging the x values in. So like in this case, I'm going to plug in 0. Okay? And whatever answer I get goes in the y side. And I would do that, same thing, and just keep working my way down the list. Yeah. Because the only way the x works is if I put it in the y equals, because then the calculator automatically starts putting all the numbers in for me. If you're just doing your regular calculator and you put in x, the calculator's like, okay, now what do I do? It doesn't really know. So that's why if I'm kind of doing it manually, it looks like I'm getting whole numbers. This is good. I can go ahead okay, and even if it's just 3 numbers, okay, that's usually going to be enough to give me an idea of where this graph is going to be heading. Now, do I want to look and see if a negative does something? Sure. If I wanted to take a look at one negative, I could. Now again, if I'm doing the negative, I need to use the negative button, the one in white, not minus. So let's say I try -1 out. Okay. It just lets me see that it's going to keep coming down. Now, if you start plugging in positive numbers and you're getting the real decimally ones like we did before, try a couple of negative numbers. Just try a few numbers until you can get a decent looking graph working with things. And again, here, my number going to the exponent is bigger than 1. And that's a way, just looking at the graph, that I can know its growth. Whether I had a picture or not, I should be able to look at that and know basically what the graph should look like. Okay?
What would 1, 3 be?
Because this, whatever number I'm taking to this x exponent, always tells me before I even look at a picture if it's going to be growth, if it's going to be going up to the right, or if it's going to end up being decay. So these numbers, if it's bigger than 1, my graph's going to go up to the right. If it's less than 1, my graph's going to go down. It's just me being able to see from the equation what things are going to look like.
So why is it directly?
That's just these in their general form. That's the general form of things. This is the value that tells me how the growth or decay works. So yeah, I'm just letting you kind of see that again, kind of as a little bit of a review. So then you start going through and you're like, okay, you know, I can play with the calculator, get some values and graph these. But as you start to flip through the packet, you get in a ways and you're like, wait a minute, now there's like a zillion different graphs here. You know, what's going on? So I'm going to zoom out a little bit here. Oh boy, it's into one of its famous crazy scanning modes here. Just a second. It has a mind of its own sometimes. Okay. So I get to here and I'm like, well, what's up back here? Why are all these pictures here? Basically what I'm asking you to do is figure out which one goes with, you know, which one's the right pick. So here's what I would do when I get back here. I'd go back to y equals, and I'd clear it out, and I would type what I see, 3 times 2 to the x. And there's a couple of things that I could do to figure this out. Let's say I try to graph it first, just look at it. Oops, that's not how I do that. There we go. I notice it goes up to the right. So which choices does that eliminate right away? A and C. Because if you look on yours, they're both going down to the right. So it's not going to be A or C. So then it looks that way. If I'm not sure, here's the one other thing I could do. If I do second graph and look at the table, notice on letters B, let me move those to where you can actually get those into the screen here. Notice where B and D are crossing at 0. Well, B, that looks like that's going through at about 3, and that's what this chart says it's going through at. If I look at D and I look down at 0, it looks like it's basically going through at 0, 0. That doesn't match my chart. So just with those 2 bits of info, I can figure out it's B. Otherwise, I could just plug some values in to see which one works. But that's going to be the easiest way, because you'll always cancel a couple of them out right away. So that's what's happening when we get to the multiple choice part of things on this. But this sheet here, our focus with this is practice, practice, practice once you're done with the redemption quiz, okay? So this is an assignment after we get done with the quiz. So I'm going to put this off to the side for a minute. All right. Since it's been a little while, about a week here, since we did some of the stuff with exponents and things, I wanted to take a minute to go back and do a few of these. And like I've said before, if you've got your notes on exponents or polynomials, those are free game on this quiz. So, all right. When I'm multiplying, yep, we're still going to multiply the numbers in front, multiply the coefficients, but we add the exponents, okay? So 2 and 4 is 6, okay? And this is one I'm just doing up here, so this wasn't one that we picked up in the front or anything like that.
I have a question back on that side.
Okay, I'll come back to it in just a sec. So when I get to division then, what do I do with the exponents on my variables? Do you remember? Okay, we're going to subtract them. Now, I do not subtract the numbers in front. That I still reduce like I would a fraction. So if I wasn't, if I wasn't sure what that was, I always could go back, type it into my calculator, and do math, enter, enter, because I don't want a decimal. But then with my exponents, 4 minus 2, because I subtract is 2. Bigger ones on the bottom. That's where my x goes. For my y's, 3 minus 1 is 2. Bigger ones on top. I get my answer. If I've got parentheses, that's power to power. It goes to the number and to my exponent. Multiply your exponents. And remember, this is 2 to the third power, not 2 times 3. 2 to the third power is 2 times 2 times 2, which would get me 8. Okay, and I'm not going to do huge, crazy ones on this, just some basic stuff. And basically the only other rule that we haven't done anything with yet is when we deal with a negative exponent. Negative exponents need an attitude adjustment. So any negative exponent gets flipped. It makes it positive. And then I just simplify whatever's left. Well, now when I flipped it, I'm multiplying these, so I add them up. So again, it's just kind of going back over some of those parts of things. And then we do a little bit with the polynomials. Okay. What would my degree be of this binomial? Okay, 5, because remember, the plus or minus separates terms, and then you just add the exponents up within a single term, and whichever one's biggest is the answer. Okay, but it's not for the whole thing, it's just for a single term. Then if I want the type of polynomial and the lead coefficient, now there's one trick to this. Most of you are good at saying there's 3 terms. That's a trinomial. That's true. But here's the catch. Before I can tell the lead coefficient, I have to have this in standard form. If you remember standard form, absolutely. I have the biggest exponent first, and I work my way down. So x to the third, x to the second, and then my number. And my lead coefficient, once it's in that form, is just the number at the start of the problem, 4. And that's all I've got to do there. And then we talked about multiplying. Some of you like to foil this with the lines and making the smiley-faced guy. Some of you were bigger fans of the box because it organized you and you couldn't forget something this way. No matter which way I do it, multiply the numbers in front, your coefficients, and add your exponents. 2 times 1 is 2. I just have an x. 3 times negative 3 is negative 9. And I just have an x. Negative times positive is negative. And then I just start in the upper left-hand corner. There are my like terms. 2 and negative 9 is negative 7. And the minus 3 on the end. It's just kind of reviewing some of these things, because what we're going to be doing tomorrow is we're actually going to be starting a unit review. There's one part that's left. But by, I think it's Wednesday or Thursday of next week, we're going to be done with this unit. We're going to have gone through a big old review packet together, and we're going to be ready for the unit test. So that's kind of where we're at right now. So what we will do here, I'll get this out of the way, is to get you started on the redemption quiz. And then once you get done with that, if you've got any questions going on the assignment with the graphing of growth and decay, I can absolutely help out with those too.